Alrighty, the first class of October for NHA is us. Of all the classes, we are the very first one for the month of October, and that is awesome to know. Got a good crew here, nearly the entire class on. Got Josh on with his video, so that's fantastic. And all the gals do not have their videos on, which is okay. A couple quick announcements for us here by way of video. I am recording this. It will be on the YouTube channel eventually. And if you ever need to go back and look at things, that's fine. Also, this lesson is what I would call elementary. It is not quite at a pre-algebra level yet, so it's under that umbrella of review. And so on these easier weeks, things that you probably have already learned, maybe even today's lesson you learned in the third grade or the fourth grade, we want you to make sure you're paying attention and make sure you understand it. The reason they review is they want to make sure you understand the concepts of the previous maths. So when we get into the harder stuff, as I've told you a time or two before, the math really gets to be on a pre-algebra level around Thanksgiving time. So the first 7 or 8 weeks is what we call review oriented, and it kind of gets us ready for some of the algebraic concepts that we're going to be introducing to you here within the next few weeks or months and such. So, and it will get tougher. So if you're still not quite fully challenged yet, stick with us around Christmas time, or winter break time, I should say. You'll be saying, Mr. Soto, it's harder now. And I'll say, remember I told you back in October, enjoy the easier lessons because the more difficult stuff, or the stuff that's new to you and a little more challenging, is on the horizon. So that being said, let's go ahead and let me pull the whiteboard up here. That's the one we want right there. And so make sure that works. And it does. I usually do that beforehand, but last couple weeks I haven't been. So, all right. So lesson 17, again, what you're going to want it, where you're going to want to be for the teaching textbooks curriculum is through after day through lesson 18, which will include one test. I think we have one more test just coming up right away. So by maybe next week sometime, you'll want to have completed 9 lessons, 2, 4, 6, 8, 10, 12, 14, 16, and 18, plus the 2 tests. And finish the packets. If we don't finish all the work, we don't always do all the work, depending on how much work there is. Finish the packets and turn those in. That's kind of minimum of our recommendation for you. You're more than welcome to do more. And if you're, again, going with what others are doing, that's fine as well. So, I mean, like if ES is recommending something different, that's fine. So let's go ahead and look at 17. Again, this is relatively review for you. But again, the emphasis here is we want to see.
Hi.
Hello. We want to just make sure we understand the idea of when you add and subtract with decimals. Okay. Again, the key thought on decimals is this: where the decimal is to the left of the decimal, you have more than one. To the right of the decimal, you have less than one. And in positive numbers, it's more than 0, if that makes sense. So remember I showed you the number line? If you have -1, 0, 1, 2, 3, 4, you can take this section right here and you can make a number line out of that, meaning you could say this is 0 and this is 1, and there's actually value in between. And if you think of money, this would be $1, this would be no dollars, and this would be 50 cents, because 50 cents is halfway between $0 and $1. And let me show you really quickly how a tape measure works. I showed you on Tuesday, and again, this is kind of a little extra for you because I want to teach you things, and on the easier lessons, I'll sometimes throw a little tidbit of extra. but I want us to see how fractions work like on a tape measure. I might even have a tape measure in here. I do, check it out. So if you look at my tape measure here, you can see where it has the little hash marks in between, and then below it, it has fractional components that correspond with, so you can see that you have each of the fractional parts. So again, showing you fractions. Fractions by definition are less than one. We learned that on if they're a proper fraction, and if it's a mixed numeral, to the whole number is the more than one portion, and the fraction is whatever's left over. And it's like if it's 7 3/4, it'd be 7 wholes and then 3/4 of one more, right? So if you had and I can show you that by boxes like I did in a minute. Let me just show you how this will work. I showed you how it would work with decimals from a number line, meaning just quickly review like this. Let's say this is just 0 and 1 here, and you got like 0.1, 0.2, all the way up, okay? Let me show you how it works with fractions, all right? Here we have 0, we have 1. This would be half, okay? So, and you could make any portion. You could have between 1 and 2, you also have a half, but it's 1.5. Between 11 and 12, you have a half, it's 11.5, or 12, and depending on where you are. But we're just on 0 here, so this is just a half. Now watch. This here is 1/4, and this is 3/4, okay? But I also want you to see this. We can express 1/2 as also 2/4. So look, 1, 2, 3, and this would be 4/4, right? Because any number over itself is equal to 1. So look at 1, numerators now, 1, 2, 3, 4. Okay, now watch this. This is going to be 1/8. So this would be 2/8, which reduces to 1/4. This is going to be 3/8, which is, this would be 4/8, which 4/8 reduces to 2/4, which reduces to 1/2. So this is 5/8, 6/8, 7/8, 8/8. So as you can see, every time you go between this is going to, now watch. We went 2, then 4, then 8, and you're like doubling every time. So now this is 1/16, 2/16, which reduces to 1/8, 3/16, 4/16, 2/8, 1/4, 5/16. Now, when you get into a tape measure again, it'll probably go to eighths, not the 16ths. But when you get to like tools, like your dad might say to you, "Hey, go get my 3/16 socket." Well, that's just a measurement, and the 3/16 is between the 1/8 and the 1/4, right? So you can see how these measurements go. But you can look here again. You can look between the 2 and the 3. You're going to have the half in the middle, then the fourths split that. Then the eighths are between all those. And this tape measure only goes to eighths. But you can go to 16ths, you can go to 32nds, and each time you double, 64ths and such. And when you get a really, really, really small measurement. So that's just free for you. I want you to see how a tape measure works. And again, if you're measuring something, you're going to do some work around your house, maybe put a nice border on the top of your room around the perimeter there. So you got to measure, you get your tape measure out. You can put it out and you can say, I need, 12 feet and 7/8 of an inch to go measure this that I'm going to cut and put up onto my wall. So having understanding of how that works is important. Okay. So let me just say this again, that's free for you. I wanted you to see the cross section of a fractional part and how that relates to measurements, including like on a tape measure. And even baking, if you like to bake, and you might say, you might have a recipe, and so here's Mr. Soto helping you out in random things of life. Let's say you have a recipe, and the recipe you need to triple the recipe because you're making, it's cookies, but you're making enough cookies for Thanksgiving, and you have, the recipe will make enough to make 8 cookies, but you need over 20 cookies because there's so many people there. And if it calls for 3/4 cups of flour, well, then you can just triple it. Here, you'd multiply by 3. I'm going to add it since we've already added fractions, but I could show you how to multiply it a little later. Denominators are the same, so now you have 3, 6, 9. You have 9/4. Then you say, well, how much is 9/4 in a mixed numeral? 4 goes into 9 2 times. It's with 1 left over from 8. I need 2 1/4 cup of flour because the recipe that makes 8 cookies calls for 3/4 cup of flour, but I need to triple it because I need to make over 20 cookies. So I'm just going to add 3 times 3/4, 3/4, 3/4. I get 9/4. And so you think, Mr. Soto, when am I ever going to use math? You use it a lot more than you think. Okay, so that being said, let's go back to the first problem. Let me just erase all this and start over. All right. I'm going to ask you for a thumbs up and a thumbs down or a pointer finger in the middle on just kind of and you don't have to know this, but because it's not part of the curriculum, but I just think it's helpful to learn these things. If you kind of understood how the number line 0, 1, and you take that out, and inside of that is also a number line, you can just keep on doing that. And how those fractional parts work, like the 1/2 is in the middle, then halfway between both of those is 1/4 and 3/4. Then between the 1/4 and the 0 is a 1/8, and so forth. If that kind of made sense to you, give me a thumbs up. If it's a little foggy still, maybe a pointer finger in the middle. And if you're completely lost, give me a thumbs down. On the count of 3, 1, 2, 3, go. Okay, perfect. Very good. Now here, this again is 3rd grade work, and you're all in junior high school. But again, I'll remind you how it works. You always line up the decimal points when you add with decimals and when you subtract with decimals. It's already done for us here. The next lesson will be a little bit tougher because there'll be some missing spots, but this, again, is relatively easy. 5 plus 0 is 5. 2 plus 5 is 7. Bring the decimal point down. 7. 17.75. There's our answer. Again, not too terribly difficult. Let's go ahead and subtract. 6.83, this is number 2, minus 3.97. Okay, here we're going to have to borrow. We'll borrow 1 from the 8, make it a 7. The 1, because we're going a whole place value over, is like a 10, so we'll put the 1 there. So 13 minus 7 is 6. But now we can't subtract, since 7 is less than 9. We have to borrow 1 from the 6, make that a 5, make that 17, and that would be 8. 5 minus 3 is 2. Bring the decimal point down, 2.86. Okay. Again, on these problems, I believe you've done this work before. If you fully understand how to do this, give me a thumbs up. If you're still not 100% sure, you give me a thumbs down. On the count of 3, 1, 2, 3, go. Okay, good. Anybody not know how to do these kind of problems? Again, this is, I would say, 3rd grade work, and you're all 7th, 8th grade, or 6th grade, or 9th grade, or somewhere in that range. So most of you have learned how to do this. And again, if you haven't, or if you don't know how to do this, I'm going to just admonish you to really catch up quickly and really just be laser focused on these lessons, because these are things that are really important for foundational math to understand how to do. So that being said, let's have you do number 3 and 4, and then you can send me over your answers by a chat. If you want to send them to me directly to me, that way people don't see your work, for 2 reasons. In case you get it wrong, I don't want you to be embarrassed to the whole class, and also that other people don't see your answer and you could potentially affect them. And I'll do this for you just in a second. Again, I don't. I'm gonna go ahead and you keep on working, and then you can send those over to me. Let me get the chat going. Okay, so far so good. Good job, Lindsay. Lindsay. Anybody else still working? Let me show you what we did here. 8 and 1 is this is for number 3. 8 plus 1 is 9. 5 plus 2 is 7. You're just going straight down. You drop your decimal. 4 plus 9 is 13. So you put the 1 here and the 3 there. Then you add the 6 and the 1 together to get 7. And then the 1 just comes down. So 173.79. And I'll go ahead and do this one here. 7 minus 3 is 4. 4 minus 1 is 3. I have a 0 here, so I have to borrow 1 from the 9. I make it 8. The 1 I borrow from the 9 is a tens unit, so I put it there. Makes that 10. 10 minus 6 is 4. This is now an 8. So 8 minus 5 is 3. And 4 minus 1 is 3. 334.34 is the answer. All right. So that's not too terribly difficult. Let's do this. I'm going to let you finish the rest of those on your own. Turn that in. That's not too terribly difficult. You have 4 problems to do in that first section. We'll do 9 and 10, which is the word problems. Does anybody want to put your audio on and read question 9? Sure, Mr. Soto, I can do that for you. Anybody? Okay, Mr. Soto will read it then. Who speaks to himself in the third person? When he was a pup, Max, we had a dog named Max, 18 years old, and he just died this past summer. He was a month shy of his 18th birthday, which is like 120 something, 127 years in dog years. So I'm so sad. And his name was Max. When he was a young pup, Max weighed 24.6 pounds. After reaching adulthood, Max grew to weigh 78.4 pounds. How many pounds were added in between? Okay, so now here we're going to have to find out. Again, those first ones were a bit easier. We can understand that. So we have to ask ourselves, are we going to add or are we going to subtract? Okay, so because the word add is there in the problem, it might trigger you to think, well, I'm going to need to add this. However, it's got to make sense for you, okay? If you started at 24 pounds, then he went to 78 pounds, the in between would be the difference of those two. And when you see the word difference in math, that is a subtraction term, the difference between two. Okay. So, and by the way, there's something called inverse operation. The inverse of addition is subtraction, and the inverse of subtraction is addition. Let me give you an example of what I mean by that. 3 plus 5 is 8. 8 minus 5 is 3. 8 minus 3 is 5. So this is inverse operations, and you're going to be learning that a lot in algebra, algebra 1, algebra 2, pre-algebra. And you're going to need to know how to inverse operate things in order of operations and things like that. So if you notice here, these are called addends. They're the two terms that are put together to make a sum. Anytime you have the sum of two addends, you could take the sum, which is 8, and subtract either addend from the sum to get the other addend, because the inverse operation of addition is subtraction. Okay? And so one thing about this also is a couple things. The order does matter in subtraction. The order does not matter in addition. So you got to make sure you put the 8 first, because 5 minus 8 is not 3. It's actually negative 3. Okay? But if you take the sum of two addends and subtract either addend from that sum, you will get the other addend because they're inverse of each other. The inverse of addition is subtraction. The inverse of subtraction is addition. Okay. That being said, they want you to see that in lesson number 9. They're saying if you added his original weight to the weight that he gained, you would get the sum of his total weight as an adult, which means like the 8 minus 3 equals 5, but we're missing the in-between weight. So we have to take the total, 78.4, and subtract the original weight. And by doing so, we can find out how much weight he gained in between, max. And so we know that and we always could check our work. His original weight plus his added weight would equal his adult weight, because the inverse of subtraction would be addition to check our work. And by the way, equals is a term that means the same on both sides. You've not thought of it that way doing math thus far, but when you get into algebra, and we're in pre-algebra now, equals means the same on both sides. Back to our 5 plus 3 equals 8, because I like to give you really simple illustrations. That's why I did the 5 plus 3 and the 8 minus 5, so you can see it, right? I don't want you to think of this anymore as 5 plus 3 equals 8. I would rather have you think of it this way. 5 plus 3 is 8, and 8 is the same as 8. Equals means the same on both sides. Okay? And this really comes into play as you get into solving equations, which we're going to be doing in just a little bit of time. Some very simple equations. And as you get up into pre-algebra and then in algebra 1 and algebra 2, this is something you'll be doing a lot of moving forward. Okay, so that being said, the answer to number 9 is 53.8. On this question and this question alone, that makes sense to you. All the things I said about the dog's weight when he was a puppy, the total weight, you add this and this to get the total, so you have to subtract it. And so it says the word added in between, but because of inverse operation, we have to subtract. On the count of 3, if you understood that, give me a thumbs up. If you're a little lost, give me a thumbs down. On the count of 3, 1, 2, 3, go.
You put 14 instead of 4.
No, I put the 4, but I had to borrow one. See what I mean?
Oh.
Yeah. So it was 4 originally, and when I borrowed one, I put the 1 there, so I can say 14 minus 6 is 8.
Oh, okay, I see, I see. My bad.
No worries. No worries at all. I'm good for a hash mark a lot. So, but this particular one, it was 4, but I added the 1 there for the 14. All right, let's do this. Do number 10. It's the same exact structure. Again, you got to make sure, in addition, you don't have to worry about what the order doesn't matter, but in subtraction, you have to make sure the order is correct. Give me an answer when you get number 10. A tree that was once only 6.74 feet tall over the course of 10 years grew to be 23.46 feet tall. How much taller in feet has the tree gotten? So you're going to take the difference in the middle of how tall it got minus the original tree or the baby tree. Yeah, that looks good, Lindsay. All right, good job, Lily. Lily of the Valley. When you're done, you can look at the board to check your work. All right. Again, not too terribly difficult, but let's look at the next page a little bit harder. Yeah, this is, I forgot to tell you what the answer to number 10. It's 23.46 is how after 10 years where the tree was. 10 years prior was 6 feet, 6.74 feet. The difference is 16.72. And again, we oftentimes don't think of these decimals in terms of measurements, but that's okay. We can. I mean, and one thing that's just kind of mind-boggling is because there's 12 inches in a foot. Let me just tell you something. Okay, this is a little advanced for you. So if you don't pick up on this, don't worry about it. Okay. Let's say one of you is 5 feet 6 inches tall. I don't think anybody's that tall yet, but maybe somebody is in our class. Josh is probably taller than that, actually. Okay, 5 feet 6 inches tall is the same as 5 feet 5.5 as a decimal. The reason being is because there's 6 inches is there's 12 inches in a foot, if that makes sense. So 5.5 in the decimal is 5.5, right? 5 feet 6 inches is the same as 5.5. So 5 feet 6 inches is the same. I'm not going to put this decimal here just because I don't want to confuse you. So 5 feet 6 inches is the same as 5.5 feet. And that it does get a little confusing because there are 12 inches, and so the decimals don't work out perfectly when you go from the decimal to the feet and then the inches. And that's why I believe they use fractional parts on the tape measure as opposed to decimal parts on the tape measure, as to not confuse you in that regard. So if that last 1 minute confused you at all, don't worry about it. It was a free bonus for those who want to be challenged, but that's just something to keep in mind. Let me just say this. We use base 10 a lot. Everything is multiples of 10. The whole metric system is in multiples of 10. And a lot of our like scientific notation is in multiples of 10. But for a long, 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 long time, in like ancient civilizations, they used a phrase called base 12. One reason why they do that, like we count to 10 with 10 fingers. Makes for easy counting when you're 3 years old and 4 years old. But they used to use base 12 because they'd count on your knuckles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And also factors of 12, 2 and 3 and 4 and 6 for easy multiplication. Okay, so that's why there are 12 hours in a 24 hours in a full day, but 12 and 12, base 12. 12 inches in a foot, base 12. 12 eggs in a dozen, base 12. If you order things to this day, if you go and you order something and you order a gross of something, gross, does anybody know how many are in a gross? Anybody? And I mean, it's a term you use today. If you went and you ordered a bunch of pins, which I order for our church once or twice, once a year I order, and they're usually in a gross. I'll get a gross of pins. It's 144, which is 12 times 12. So you see that in lots of civilizations, they used like the old Greek Empire and such, they used 12 as base 12. So, and I say all that to say the reason that it's hard to go from a decimal of inches of feet and inches to a fraction to an actual feet and inches, it kind of has a little bit of, you got to be very careful when you do that. So, anyways, that's all free for you. On an easy day, I got to give you something that helps you with math. So, but very interesting. How many at least think that's kind of interesting, that base 12 versus base 10 and such? Give me a thumbs up. Thumbs down if it bores you. And it's fine if it bores you. Count of three. If it kind of interesting, at least count of three, give me a thumbs up. One, two, three, go. Okay. All righty, let's do this. Let's go to number one. Now we have some open spots here. Okay, they've already lined them up for us. They're asking us to add this, okay? Anytime you need to add a zero, you can if you want to. Sometimes you'll have to, okay? But adding this zero right here doesn't change the value. I like to give you examples of money, okay? If you had $7.50, that's basically 7.5. 7 whole dollars, 0.5 we know is a half, right? But you think that 0.5 kind of confuses me. Let me do this and put a zero here, and it's 50 cents, okay? And so, again, 7.5 is exactly the same as 7.50. They're the same on both sides, okay? So I can add a zero here if I want to, just to help me make it make sense. But we don't have to even add that zero on this one, because we can just say 5 comes down. 8 plus 3 is going to be 11. So 8 plus 7 is 15. That's 16. Bring my decimal down. 9, 10, 11. 2, 3, 4. 416.15. So I can add the 0 here. 5 plus 0 equals 5. Or I can even leave it blank. It doesn't matter. Okay? And again, when you get to that decimal, the decimals have to line up. Okay? So what you can't, and they've already lined them up for us, but what we can't do is we can't do this. I'm going to put no, no, no on this. Don't do this. Don't go 218.85 plus 3.791. Okay. So in the original problem is 197.3 plus 218.85. If you do this, you're going to be wrong. Okay, let me give you an example. Let's say we're going to add our money together because we're going to go on a math field trip and we all need to bring money. Okay, let's say somebody brings $5.50 and somebody brings $6 and somebody brings 75 cents. Okay. Now watch, I can do this. 5.50 plus 6 plus 75 cents. This would not be the way to do that, because watch, see this 6? This 6 is actually 6.00, right? So if I add it here, I have 6 and 5 is 11, 7, 5 is 12, 13. So if I do it the wrong way, I only have $6.31 total. And I'm off by a lot, when actually I have 5.50 plus 6.00 plus 0.75. So I actually have $12.25. Okay, so you got to make sure you keep the decimals lined up. Here I have the decimals lined up. So you have the 5.50, the 6 points, and we don't even have to put those two zeros in if we don't want to. We can just do this. Either way, if we like to put them in there because it helps us just to see it, no problem at all. But if you line these decimals up, easy cheesy lemon squizzy. 0 plus 5 is 5. 5 plus 7 is 12. 6 plus 5 plus 1 is 12. And so $12.25. So we got to make sure when we add and subtract decimals, they line up. Not when we multiply or divide, only when we add and subtract. Okay? But number two is a little different as well because we almost need to put the zero in because in subtraction, order matters. So here we have 45.1 minus 27.72. Okay, so here, now watch what we have to do. I have to add this zero here because I need to subtract 2 from it. Okay, so I'm going to take the zero there. I'm going to borrow the 1, put it here, put a 0 up here. 10 minus 2 is 8. I still have the same problem here because I can't subtract 7 from 0 because I have to have a larger value on the top. So I'm going to borrow 1 from the 5, make it a 4. I'm going to put that 1 there. I'm just moving a place value over. Base 10 right there. 10 minus 7 is 3. Okay. Now I still need to borrow 1 from the 4. 14 minus 7 is 7. I put a 3 there. 3 minus 2 is 1. 17.38. Okay. So I had to put this 0 here to make that make sense. All right. Let's do this. I want you to do number 8 because it's similar to the one to number 2. Okay. I want you to do number 8 so you can see that number 8. I'll write it out for you. Send me over an answer when you get it. And if you're ever in doubt, you can always, I'll show you when we're done. I'll let you work. I won't interrupt you. If I fall asleep, you got to wake me up. Okay, people are sending over answers. Let me pull up my. Okay, I like that. Okay, I want you, I'll show you in a second, but a couple of you are close, but there's a couple things you've done incorrectly. So again, these are a little tougher. That's good. I want us to be challenged. Um, I felt like the lesson 17 was really elementary. This here does give you a little bit more challenge because there's a few things you have to do. So no worries if you didn't get it right, and a few of you did, and a few of you didn't. So, again, that's one reason why I like you to send me the answer. So, I like you to feel like you can, put forth an effort without, the scrutiny of others. Okay, so let me show you how to do it. I want everybody to watch because a few of you got it right, a few of you didn't get it right. I do have a subtraction problem here. I can always add a 0 here without changing the value. I do it just to give me a place value from which to subtract. I've lined up the decimals. Well, they've already lined them up for me, which is fine. Okay, so I add that 0 because that's a subtraction problem. I'm going to borrow 1 from the 7 to make this 6. When I do that, I make this a 10. Okay, 10 minus 1 is 9. Now watch, 6 minus 6 is 0. I bring my decimal straight down right here. 4 minus 2 is 2. 3 minus 1 is 2. The correct answer should be 22.09. If you ever want to correct your work, or check your work, I should say, you can always add the difference to what was the subtracted value. Inverse operations, right? I told you that already. Now watch. 9 plus 1 is 10. 6 plus 1 is 7. 2 plus 2 is 4. 2 plus 1 is 3. And 34.70 is the same as 34.7. And I see that, Alexis. Yeah, that's the correct answer, by the way, for number 7. You did number 7, not number 8. So 34.7 and 34.70 are the same value. You can add as many zeros to the right or to the left of a value as you want without changing the value. And I've told you before, a lot of times, let's say you have some random problem, it's 0.9 is no different than 0.9 is no different than 0.900. All these are the same value. It's 9/10. Okay. So zeros going to that way once you have your whole number. There are some times in between the decimal and whole numbers that you have to be careful on, and we'll cross that bridge. So 3.470 is the same as 3.47. All right. Let's do this. Let's try number 6 because that's similar as well. And I think the addition ones are easier, so I'm going to let you do those ones on your own. It's the subtraction ones that are a little bit more difficult. I'm going to start working. You keep on working there, and you can send me over an answer when you're done. All right. Looking good. Again, not too terribly difficult, but yeah, we threw a different wrinkle in there. I gave you some extra teaching today that was helpful for you as well. Taught you about the number lines, how fractions and decimals are different between how they express differently. And then I told you about the difference between a foot, like 5 feet 6 inches versus 5.5 feet being the same value. That's a little bit confusing, I realize. And that was probably the toughest thing of the day. So here we go, 72.6. I add a 0 there, borrow 1 from the 6, make the 0 a 10. 10 minus 9 is 1. 5 minus 4, because 5 is greater than 4, I can subtract. 5 minus 4 is 1. 12 minus 9 is 3. 6 minus 3 is 3. 33.11 is the answer to number 6. So we did together 1, 2, 6, and 8. And Alexis did 7 also. That was correct, by the way, because she did the wrong one. But that's fine. And so the rest of those you can do on your own. And we try to be done at 9:45. So does anyone have any last minute questions? All right. We will call that a day. I will see you on Tuesday.
Thank you.
You're welcome.